Well, here we are. We've made it to the end of the experiment section 1.6. Our last kind of experiment is called matched pairs. Matched pairs is an example of a randomized block design where the blocks consist of two individuals. So we take all the individuals in the experiment and we try to pair them up as close as possible so they're just two almost identical individuals exposed to the treatments. And then we can see supposedly that way that the treatments are what are responsible for the change and not the differences in the individuals. So we do the best we can to match them up all the way down to pairs. So here's an example. That's why it's called matched pairs. So suppose we had 6 students and we have the number of push-ups they can do. It's listed here. They're coded to protect the innocent. So student A can do 1 push-up, B 1 push-up, C no push-ups, D 10 push-ups, E 0 push-ups, and F 10 push-ups. Now that's probably not going to happen in real life, but here we can pair things up exactly because we can pair up A and B. They can do 1 push-up each. C and E can do 0, and D and F can do 10. But even if they didn't have that exact matches, we could match them up as close as we can by the number of push-ups they can do. But just to make it clear what we're doing, we've got exact matches there, so we really don't have a choice. A and B are going to be together, D and F are going to be together, and C and E are going to be together because they have identical push-up capability now. We want to see if a new exercise program can increase the number of push-ups more than the traditional one. So we have a new program and the traditional one to compare. The explanatory variable then will be which program are you in? Are you in the new one or the existing one? The response variable will be the number of push-ups at the end of the program. Okay. So we said the matched pairs process matches students by how many push-ups they can do now. So we got C and E together, A and B together, and D and F together. And then we randomly assign the treatments. The treatments are which program are you in, new and existing. So there's a random assignment here and a random assignment here for A and B, picking the programs that they're in and so on. And the reason for the random assignment is even though we matched them up by what they can do, we randomly assign so that the things we can't measure that might have caused one of them to be more likely than the other to be successful in creating more push-ups. We didn't pick them accidentally. We didn't pick them in a way that we might systematically have chosen the stronger person for each of those groups because we just said we'll just do it randomly to try to avoid doing that, even though we might try not to. Somehow we might pick them in some order. Maybe the way they appeared on the class list, we'll just take the first one. Maybe that's the wrong way to do it because of the way they sign up. There's different things that might influence who got one treatment that we might not even notice. If we do it randomly, then there's no influence here. They're equally likely to be assigned either treatment. And so that keeps those other variables from maybe having such a strong impact on the results because you've randomly assigned them, the individuals. So whoever might have been more likely just because of their characteristics to produce more push-ups, they're randomly assigned to the treatments. That we're trying not to systematically put them in the new group or in the existing group if such a thing exists between the two people. We've already made them as close as we can based on the data we have. Then we randomly assign them after that to make sure we've not systematically chosen or to try not to systematically choose people who are more likely to do push-ups, more push-ups, and stick them in one of the groups. That's a long-winded way to say randomization helps you keep other factors from influencing the outcome because you've randomly assigned those other factors to the groups. And so the main effect is supposed to be the treatment you're studying and not those other variables. Matching assures the response is not, tries to assure response is not due to fitness at the start because it's a way to gauge fitness, and fitness at the start could be responsible for how many push-ups you can do at the end. The difference between 1 and 0 push-ups might not be meaningful. Maybe 10 is. I don't know. And random assignment further assures fitness at the start is not responsible, or other variables you didn't measure are not responsible. We try to do that. That's how random assignment works. It tries to randomly scramble up those initial variables so that they don't systematically get associated with whatever the better treatment is or whatever the worst treatment is, or it creates an illusion that one treatment's better than the other. So that ends the experimental design part of the section, and that ends the slides I have to make for this section. And I think that would be the end of that. So I'm ready for a new section. How about you? It's coming up.